Do you know what is the scariest thing in the world is? Not knowing how to invert a binary tree during your interview. I know you guys have seen this video a lot of time in YouTube. Hi, my name is Anindo, working as a technical recruiter at Oracle, and today we are solving the most scariest problem during technical interview so that this world is not the scariest place for you guys. So let's start with today's video of how to invert a binary tree during your interview. But before that, if you like this video, don't forget to like and share this video, and if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with today's video. So before solving the problem of how to invert a binary tree, let's first understand the problem. So the problem statement tells that given a binary tree over here, we have to invert each and every node of the binary tree. So let's see what does it mean. So inverting a binary tree means that we have to swap the left child with his right child, which means that if we start with the inversion of this binary tree, then the resultant binary tree will look something like this. So over here our root will be the starting point of our inversion. So this will be as it is. Now we have the two children of this parent node. One is 2 and another is 3. Now what we have to do, we have to invert this node over here, which means that the left child will get swapped with the right child over here, which means that over here the left child after inversion will be 3 and the right child over here will be 2. So right now 3 will be the left node and 2 will be the right node of the parent node, that is 1. Now if you see the subtree of the root element 3, you can see that the children of the node 3 is 6 and 7. So over here we have to again swap the left child with the right child. So after inversion, the left child will become 7 and the right child will become 6. Similarly for 2, the left child is 4 and the right child is 5. And after inversion, the left child will be 5 and the right child will be 4. So this is the expected result that we need after inversion of the binary tree. But very frankly telling, this is not at all a scariest program during interview. And we can easily solve this program using the algorithm that I will be providing right now. So there can be two ways of solving the problem. One is the recursive way of solving this problem, and second is the iterative way of solving this problem. But I have seen in most of the cases, people likes to remember the recursive problem over here because the recursive solution is always short and crisp. But the problem is they try to remember the solution and during the interview, they normally forgot the actual solution and just couldn't answer this question. And that is the only reason I mostly prefer the iterative way of solving this problem, because the iterative solution of any problem on binary tree is mostly straightforward and simple. And if you know how to solve this problem in an iterative way, you can normally solve any problem during your technical interview. So the process by which we will be solving the inversion of a binary tree is by the iterative way, and we will be using the level order traversing for that. So believe me, if you know the algorithm of level order traversal, you can solve any problem on binary tree. So let's start with solving this problem using level order traversing. So what we will be doing over here, we will be traversing each and every node over here in the level order manner. And while traversing each and every node over here, we're gonna solve the left and the right child over here. And in doing so, for each and every level, we will result into the inversion of the binary tree. So if you are not familiar with the algorithm of level order traversing, I would highly recommend you to go through the video of level order traversing first so that it will be damn easy for you to solve this problem. So if you have not yet gone through the video of how to do a level order traversing, I will attach the video in the eye icon coming over here. So let's start solving the problem of how to invert a binary tree over here. So over here, let's write a function of inversion of binary tree. And over here, we will be passing the root node, that is nothing but this node, that is the starting point of our tree. So the way we will be solving this problem is by using the level order traversal. And as you know, for solving the level order traversal problem, you need an additional data structure, that is a queue. So the first thing that we have to check that whether the tree is empty or not, because if the tree is empty, there is no need to invert the tree. So we'll first check that whether the root element is null or not. And if the root element is null, we will return the root element, which means that it is already inverted because there is no existence of any tree. But if the root element is not null, which means that there exists a tree over here and we have to do our operation of inversion of the tree. So what we will do, we have to first do a level order traversing, and for that we will be declaring an additional data structure which is called a queue. And each element within the queue will be of type tree node. So if you are not familiar with my previous video, so let me tell you one more time that tree node is nothing but a data structure which comprises of three attributes. One is the data, which comprises of the value over here, and number two, the pointers of the left child and the right child. So this is basically the definition of the tree node over here. So let's proceed further. So the first thing that we do on a level order traversal is we put the root element in our queue. So let's put the root element within our queue. And we have to iterate over this queue until and unless the queue over here is empty. So we'll write a while loop and check that whether the queue is empty or not. So until and unless the queue is empty, we will keep on iterating over this tree. So what we'll do, for example, right now we have an empty queue over here. And over here we are putting the first element of our tree, that is 1. So over here 1 is the element we have in our queue. So the first thing we have to do is we have to pop this element from our queue, which is our current element. So this will basically pop the first element out of the queue. So right now we have the current element as 1 and our queue is completely empty. So after getting the first element out of the queue, we have to start our process of inversion. So what we will do, we will first invert the left element with the right element over here. So the process of inversion of left child with the right child is pretty simple. First we will check that whether this current element is not null, and if the element is not null, then we will change the left child with his right child. So over here you can see this is a simple logic of swapping the two values between the element. So let's understand what we are doing until now. So for the first time we are inserting the root element within our queue, that is 1, and we are iterating over this tree until and unless this queue is empty. So since the queue is not empty because we have the existing value 1 over here, we are entering this while loop. And over here we are popping out the first element of the queue, which is 1. And if the element 1 is not empty, then we are swapping its left child and the right child over here. So over here you can see that the current node is not null, and that is why we are swapping the left pointer with the right pointer. So I hope this swapping logic is quite simple to understand. So right now since we are done with our swapping logic, which is the code of our inversion algorithm, we will proceed further with the level order traversing. So the next step of level order traversing is we have to check that the element over here have a left child or not. So if the element over here have a left child, we will put that left child back into our queue. And similarly, if the element have a right child, we will also put that child into our queue. So let's write the logic accordingly. So if the left child is not null, which means that there exists a left child for this current element, then we will push this left subtree within the queue. And if the right child is not equal to null, we will push the right child in our queue. So let's understand what we are doing over here. So at the very first, we have pop out the first element of our queue, that is 1. And since element 1 is not null, we are swapping here the left child with its right child. Which means that in the initial tree, the left child was 2 and the right child was 3. But after applying the logic of swapping, the left child became 3 and the right child became 2. And after that, we are checking that whether the left child is null or not. So in this case, the left child is not null because we have the element 3 over here. And since this is not null, we are pushing the value 3 over here followed by 2 over here. And at the end, we will close the while loop over here. So let's do a dry run over here to understand what is happening. So after the first iteration, we will again come back over here and we'll check that whether the queue is empty or not. So over here you can see that the queue is not empty because we have the element 3 and 2. So the first thing we will again do is we will pop the first element from the queue. So right now our current element is 3. And over here we will check that whether root 3 is empty or not. So since the element 3 is not empty, we will swap its left child with its right child. So in our initial tree over here, the left child is 6 and the right child is 7. And after swapping over here, we will have our left child as 7 and right child as 6. And since the left and the right child over here is not equal to null, we will put that back into our queue. And again in this way, we will iterate over the left hand side subtree, and at the end we will get our desired result over here. So I hope this solution was pretty simple and straightforward, and the main implementation or the main logic of solving this problem is number 1, you have to know the level order traversing of our binary tree, and number 2, you have to know the logic of swapping the left child with the right child. So using these two algorithms of level order traversing and swapping, you can easily implement the algorithm of inversion of a binary tree. And over here at the end, we will return the root element from here. So I hope this solution was pretty simple and straightforward, and this question is not a scariest problem for you anymore. So if you have liked this video, please do like and share with your friends, and if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on the next video where we will be solving another important question for technical interview. So see you on the next video. Thank you.